So in this video I want to look at the idea of limits, which is kind of foundational to what we're going to do with calculus. And probably more important with limits is not as much understanding what a limit is as understanding what it's not, because it's a common confusion. And really a limit is saying what is the function approaching, or what is the dependent variable approaching as the independent variable approaches a given value. And to make that a little more concrete, let's see an example here. If we have f of x equals x squared plus 3, or 2. If I said, what is f of 2? You would just plug 2 in and you'd say that's 2 squared plus 2, which would be 4 plus 2, 6. Well, if I ask you about limits, we'll say, what is the limit as x approaches 2 of x squared plus 2? And again here we would plug it in. We'll say, okay, that's 6. However, what we are in our first example, when I said what is f of 2, we're talking about what is the value of the function when x is 2. When we're talking about limits, we're talking about what is it approaching. So it's as you're getting infinitely close to 2 with our x value, what is y getting close to? And if we think about a graph, x squared plus 2 will be a parabola shifted up 2. It'll look something like that. As x approaches 2, we're saying as we come along this curve, as x approaches 2, we'll say is a point around there, what is y approaching? Well, it's 6. And we can apply this quite easily whenever the function's defined there. We just plug the value in and that will be its limit. But something that makes limits more significant is we can do it when a function is not necessarily defined at a given point. So if, say, I ask you for the limit as x approached 1 of x minus 1 divided by x squared minus 1. Well, if you try to plug 1 in for x, the function's undefined because you'll be dividing by 0. But we can factor the denominator. That'll be the same limit. We'll have x minus 1 over x plus 1 times x minus 1. Then you'll see we cancel factors. That will be the limit as x approaches 1 of 1 over x plus 1. And then we can plug 1 in. That will be 1 over 1 plus 1, 1 half. And what we're saying in this is that on this curve, x minus 1 over x squared minus 1, as x is approaching 1, the y value is approaching 1 half. And the secret to this is that the function is not defined at 1. It's undefined. There's a hole in the graph there. But as you're getting infinitely close to it, your y value is getting infinitely close to 1 half. And we can apply this in a lot of different ways as we move forward in calculus.